Here's the story of ED8X in the CQ Worldwide CW 2015. Krasy Petkov K1LZ is a man with big ideas. His station holds the U.S. records for multi-single and multi-two in the CQ Worldwide CW contest. He decided that he wanted to win the world multi-single. He met Alex Mikhailov, RA1A, at WRTC 2010 in Russia. Alex had a similar dream, and the two combined forces. Northwest Africa is an especially good place to operate from. It is close to but not in Europe and has very good propagation to North America. Krasy and Alex looked at several possibilities and selected the Canary Islands near Morocco. These islands are part of Spain. They have efficient European infrastructure, good roads, and easy access. The U.S. and European paths are at right angles to each other. Tenerife is the largest of the Canary Islands. Its central volcano is the highest mountain in Spain. Alex bought a condo there. They met some of the local hams, and they were interested in helping. The ED8X station location is near the northwest tip of Tenerife at an elevation of around 3,000 feet. It has a clear shot to the U.S. and to Europe. The volcano blocks the less important southeast path. The property is farmland with no buildings or power. We would assemble the entire station from scratch in the 2 weeks before the CQ Worldwide CW 2015 contest, operate the contest, and then take everything down again afterwards. Think of it as field day on steroids. One thing we did not realize is that the mountain in the middle of the island affects the weather. Clouds form around it. Often these clouds are at around 3,000 feet, which happens to be the elevation of the station. At times it was wet and cold. Krasy and Alex assembled an international team of operators. Krasy, K1LZ, is Bulgarian-American. Alex, RA1A, is Russian, as is Vadim, UA1AKC. Velimir, K3JO, is Serbian. Mladen, YT6W, is Serbian. Paul, K1XM, is from the United States. And I am Charlotte, KQ1F, also from the U.S. Chak, JT1CO, is from Mongolia. Tibi, Y09GZU, is Romanian, as is Ionet, Y09WF. And Andy, LZ2HM, is Bulgarian. The station would have 2 sets of antennas for each band, one set fixed on Europe and one set fixed on the U.S. On 160, there would be 3 verticals switchable between end-fired on Europe and broadside to North America. There would be rotating or switchable antennas for chasing multipliers in other directions. And there would also be another set of antennas as far away as the contest rules allow, so that an in-band QSO station could operate with minimal interference from the run station. This would require 5 towers. Tower 1 would hold a 40-meter beam fixed on Europe and a 3-stack of ACOM log periodics for 20 through 10, 2 fixed on Europe and 1 rotatable. Tower 2 would hold 20-meter and 15-meter stacks fixed on the U.S. Tower 3 would hold a 40-meter beam and a 10-meter 3-stack fixed on the U.S. Tower 4 was supposed to hold an AD3446 quad-band beam, which we'd use to work multipliers. That didn't work out quite as planned. It would also support a 2-element 80-meter V-beam fixed on the U.S. We would put an 80-meter inverted V-beam between Towers 1 and 2 fixed on Europe, and Towers 2, 3, and 4 would support the 3 160-meter verticals. Tower 5 is close to the maximum allowed distance away at the far end of the site to avoid interference. It would hold the search and pounce antennas, a rotatable quad-band Yagi, an 80-meter vertical, and a 160-meter inverted V. Krasy and Alex bought a bunch of Russian military surplus tower. The sections are about 10 feet tall and are square. Some of this tower had been around for a while. Before we could use it, we had to clean and lubricate the mating surfaces. The base section framework is separately guyed. It has an elevator. To add a tower section, we use the elevator to raise and latch the existing sections. Then we lower the elevator and insert a tower section through the open slot in the base. The existing tower needs to seat properly atop the new section. Sometimes someone had to climb the base section to seat it. The tower has two sets of guys. Each of the four guy anchors has a winch and two wire spools. A differential mechanism equalizes the tension on the two guys. It is really slick. Raising a section requires at least 6 people, 2 at the base and 1 at each of the 4 guy winches. Tower 5 required a very long feed line. If we had used RG213, the loss would have been more than 10 dB on 10 meters. We had several lengths of various sizes of hardline. We connected them together to make a lower loss cable. This huge hardline requires huge connectors. Velimir knew how to install them. The connectors do not need to be soldered. After you have the cut cable end cleaned up, you could lock on the connector and tape it. Are you sure this isn't overkill? We pulled the very heavy hardline from the station location through the brush some 450 meters to Tower 5. The rotor cable for Tower 5 was equally long, with enough voltage drop that the rotor was glacially slow. To install an antenna, 2 people carry the boom up a stepladder to just above the tower base. This is a 7-element 10-meter beam. This one is part of the US stack. This is typical afternoon weather when the clouds come in. Now we can bolt the antenna into position. Okay, now it's secure. Then we tune the antenna from a stepladder. Then someone climbs the tower to attach boom truss wires. Then we raise the tower carrying up the new antenna. The ED8X quad-band beam for the multiplier station is shipped in 3 boxes. We received boxes 1, 2, and 1. The missing box 3 had some critical parts, including the boom. Alex located a well-used TH7 that we could use instead for the high bands. This antenna was in terrible condition due to corrosion. Vadim and Mladen cleaned it up and completely rebuilt it. This would be our 20/10 multiplier antenna. And for 40 meters, Tibby and Ionut built a four-square near the base of Tower 4 and ran raised radials. Three 160-meter verticals needed about 25 radials each. I measured and cut most of them. One way to get a radial wire over the terrain is to tie a rock on the end and throw it. Where that wouldn't work, one of us would climb. We quickly turned the access road between the towers into a maze of radial wires. After assembling the bases, we checked the resonance. This vertical is a couple of feet too long. We put a 3-element 80-meter inverted V-beam up between towers 1 and 2.
Oh, fantastic! Yeah.
During station building, we used 2 small generators, but they would not be sufficient for the contest. So Alex rented a 40-kilowatt generator. It arrived on the back of a tow truck Wednesday before the contest. We grabbed food outside. This worked better, of course, when it wasn't raining. Cressy had bought a 40-foot shipping container in Massachusetts. He built a complete ham station inside. It had a long desk, power wiring, and antenna switching. Then he loaded it up with radios, chairs, computers, amplifiers, hardline, and everything else we would need and had it shipped to Tenerife. Velimir did most of the soldering and wiring. Paul and I set up the computer network and loaded the contest software. There were 6 operating positions with a mix of radios, 3 IC781s, an FT1000MP Mark V, a K3, and an IC7800. The FT1000MP didn't work, so we swapped in a TS590S. We had 6 ACOM 2000 amplifiers, which were housed in 2 racks in the outer station room. For the contest, 2 operators could use a pair of interlocked radios as the run station during peak times, one listening on the European antennas and the other on the North American antennas. Another pair of interlocked radios could be used as the multiplier station. The other 2 radios, interlocked with each other and with the run station radio, would be the inbound search and pounce station using Tower 5. Only one signal was allowed at a time on the run band due to the interlocking, but there would be 4 operators on that band.
That's all it takes?
I'm gonna make the first use on 40 meters.
With station Spain? It'd be faster, just go break the pile up.
Velimir designed and built the antenna switching network and the interlocks. We took Thursday morning off to visit El Teide, the big volcano. The national park occupies most of the interior of Tenerife. The summit is at about 12,200 feet. An aerial tram takes visitors to within a few hundred feet of the top. Here above the clouds, the view is wonderful. Most of the crew stayed at a house we rented a few miles from the station. Cressy showed off his culinary chops. Tenerife is in the GMT time zone, so the contest started at midnight Friday night. The original plan was for all of the construction to be finished on Thursday. However, this was overly optimistic. We were still running cables a few hours before the contest, and Velimir was frantically trying to finish the station wiring. At the start of the contest, not everything inside the station was actually working yet. Some control cables had not been wired. Most importantly, the interlock for the in-band station didn't work, so we could not use those radios. One IC781 quit working. That left only one in-band search and pounce station. Velimir opened up the ICOM and was able to partially fix it. The contest operation shut down for a few hours after additional things broke. Velimir, Cressy, and Paul were all asleep at the time. When Cressy and Paul woke up, they put a run station and a multiplier station on the air. After Velimir woke up, he started repairing more things. In a couple hours, he had all of the interlocks working. So the in-band QSO station was activated. The K3 had a receiver problem. Velimir fixed it. Another IC781 died. Velimir fixed that too. By Saturday afternoon, just about everything was working. The final raw score was around 25 million points, 4th in the world. Not bad considering the problems, but not good enough. Paul asked, "What is the difference between Cressy and crazy?" He was told the answer is Mongolian vodka. Planning is already underway for next year. The log periodic antennas will be replaced with Yagi stacks. Other changes are also being planned. Expect to hear more from ED8X in the future.